PDF of a continuous distribution is shown below. First thing we want to do is find h. We can see that this is a trapezium shape, and so for a trapezium the area is a half of the sum of the parallel sides. Well, this one here is 10, and the top one, 3 to 8, is 5, times the distance between the parallel sides, which is the h. Well, that's got to be equal to 1. So multiply both sides by 2. This gives us 15h is equal to 2. And so h is 2/15. So that's part A. So we know that that one is 2/15. Let's just make some space for the rest of our working. We want to state the PDF, so we need to know the equation of this section of line. We've just said that the height is 2/15, and we can see this is 3 across, and therefore the gradient there is going to be 2/15 divided by 3, which is 2 over 45. So we've got y is 2 over 45x, and here it comes from the origin, so the c is 0. So that is going to be the first section for our CDF. The second section is very easy because it's a horizontal line. That's just going to be y is 2/15. So we've got that section as well. And then we want the final section, which would be the equation of this line down here. Once again, we know that's 2/15, and we can see that's 2 across. And that means the gradient there is 2/15 divided by 2, which is negative 1/15, negative because it slips downwards here. So we have that y is negative 1/15 x plus a constant, but we can see it goes through 10, 0. So 0 is going to be negative 10 over 15, which is negative 2/3 plus c, and that means that the constant is 2/3, which means that final section there is going to be y is negative 1/15 x plus 2/3. So we need that one as well. And so we can state our PDF. So that is going to be 2 over 45x, which applies if x is between 0 and 3. It's going to be 2/15 if x is between 3 and 8, and that one there should just be a less than. It is going to be negative 1/15 of x plus 2/3 if x is between 8 and 10, and it will be 0 everywhere else. So we want to calculate now in part C probability x is less than 2. Well, that actually only involves the first section. It's a triangle, and we could do it as such, or since we have the function we could do the integral. So we can just say that's the integral from 0 to 2 of 2 over 45 x dx. I'll just do this without the calculator. So that is going to be 1 over 45 x squared from 0 to 2, which is going to end up being 4 out of 45. Now the second part there is a conditional probability. So we've got a probability that x is less than 9, given that x is between 5 and 10. Now remember, with conditional probability of A given B is the probability of A and B, which is both conditions, divided by the probability of B, which is just the second condition here. Now, if it says less than 9 and between 5 and 10, both conditions is going to be that x is between 5 and 9. So this is going to be the probability that x is between 5 and 9 divided by the probability of x being between 5 and 10. So let's think about how we're going to calculate this. So between 5 and 8, that's a width of 3. The height's 2 over 15. So this is going to be 6 over 15. So the top here can be 6 over 15 plus the integral from 8 to 9 of this final section. So that's going to be negative 1 over 15x plus 2/3 dx. And then the bottom is going to be 6 over 15 plus the integral from 8 to 10 of negative 1/15 x plus 2/3 dx. And so we just need to calculate that. And so I've used the class pad to do that, and we can see that is 15/16. So finally, we want to calculate the CDF. So in the first section, if we say that x is here, then we're talking about this area here. And of course, that would be the integral from 0 to x of 2 over 45t dt. And that's going to be 1 over 45 t squared from 0 to x, which is x squared over 45. It's always worth checking that these things work. When x is 0, that is 0, which is good, because we need the probability to be 0 there. And we think about the area of this triangle, that would be a half times 3 times 2 over 15, which is 3 over 15, or 1/5. And if I do 3 squared, 9 over 45, that is 1/5. So that works perfectly well as our first section for our CDF. So we know that the probability needs to be 1/5 when we reach 3. And then we'll put our x somewhere in here. So for that section, we're going to have 1/5 add, this width would be x take away 3 times the height, which is 2/15, because that's just a rectangle. And that simplifies to 2x over 15 take away 1/5. So that's our second section. So let's just keep a note of these results. And then for the next section, well, let's think about what the probability is when we reach 8. So that's going to be 16 over 15 take away 3 over 15. So that makes it 13 over 15 when we get to here. And then the x will be in here, and we need to add on this area. So it's going to be 13 over 15 plus the integral from 8 to x of negative 1/15 t plus 2/3 dt. And as we can see on the calculator over here, that gives me negative x squared over 30 plus 2x over 3, take away 7/3. And of course we can check that that works at 8. So if we're given x equals 8, and it gives us the 13/15, and of course we can check that that gives us 1 at 10, as we would want it to do. So when x is 10, that is indeed 1, and so that works. That's the final part of our CDF. And so we can say that f of x is going to be 0 when x is less than 0. It will then be x squared over 45 if x goes from 0 to 3. It's then going to be 2x over 15, take away 1/5 between 3 and 8. It will then be negative x squared over 30 plus 2x over 3, take away 7/3 from 8 to 10, and then it will be 1 if x is more than 10.